Hello, my name is Spencer. I'm a sophomore chemical engineering major at Miami University, and today I'm going to take out Black Pen Red Pen's integral challenge, where I'm going to explain one of the integrals in a reasonable way that such that Calc 1 and Calc 2 students can understand. So I'm going to take up number 57, which is the integral of arcsec of x dx. So, just like any of our regular inverse trig functions, we're going to start off by using integration by parts, which I already have our derivative integral table set up. So, give me a question. Well, what do we take the derivative of? What do we integrate? Good question. So we're going to take the integral of dx, and we're going to take the derivative of arcsec of x. Makes sense. That's how you handle any of the inverse trig functions. From here, integral of dx, we get x. Derivative of arcsec, a little harder. You might not remember this very well, but in Calc 1 you did learn it, where it's 1 over x times the square root of x squared minus 1. So we're going to write that down. All right. Now we set up our plus minus, and we can start accumulating our terms. So our first term, going down the diagonal, is going to be x arcsec of x minus the integral of what's here on this bottom row, which is going to be x over x times the square root of x squared minus 1 dx. All right, so we can divide out this x, which just leaves us with 1 over the square root of x squared minus 1. Now, if you have some good intuition, you can identify this as, at this point, we can proceed with trig substitution. However, I'm going to do it a little differently. I know that in many Calc 2 classes, you learn that if you have a situation of ax squared minus b squared, you proceed by letting x equal secant theta. However, that can be dangerous in many situations where if you use that substitution, you could be left with some nasty integrals, like integral of secant cubed theta d theta, or integral of secant theta, which, I mean, they're doable, but if you're on a test, you're taking an exam, it's not going to be your best bet, because that's going to take you probably 5 minutes alone for secant cubed, which in itself is just this monstrous integral that requires by parts, and then you have to manipulate the function. So we're going to do a bit of a different substitution. We're going to use hyperbolic trig functions using this identity, which is cosh squared x minus 1 equals sinh squared x. So we're going to proceed by letting x equal hyperbolic cosine of x. From here, take the derivative, we get dx equals sinh x. Wait, I apologize, it's actually cosh theta, and it's sinh theta d theta. From here, we can also solve for theta, because we'll need that at the end. We have to substitute back in. So we solve for theta by taking the arc hyperbolic cosine of both sides, which gives us that theta is equal to the arc hyperbolic cosine of x. Lovely. Now we're at this point. Now we can start substituting in values into this integral. So we still have our value of x arcsec x minus our integral. So on top we have 1, but we have that term from our dx being equal to sinh theta d theta. So we're going to put sinh theta on top. Doesn't bad theta. On the bottom, we're going to have the square root. We let x be cosh theta, so we're going to have cosh squared theta minus 1, and we have to factor d theta. All right, we're in a good position. Now we have cosh squared minus 1. Using your hyperbolic trig identities, you know cosh squared theta minus 1 is going to be sinh squared theta. However, we have the square root of sinh squared theta, which is going to be sinh theta, and we have a sinh theta on top. So we have sinh theta divided by sinh theta, which actually, let me write this out real quick. So we're going to have minus the integral of, we're going to wind up having an integral of sinh theta over sinh theta d theta. Okay, that's good. So we can cancel out the sinh thetas, and we're left with 1. So we're taking the integral of 1. So integral of 1 d theta is going to be theta in this case. But we also recall that we solved for theta earlier, theta being hyperbolic arc cosine. So we're going to save a step, because we're assuming this is on the exam, we have to go kind of quick. So we're going to go right to our answer. So we're going to have x, arcsec x. Then we're going to have minus theta, but theta is hyperbolic cosine of theta. And we can't forget our plus c. So that concludes that. However, you could do this the other way, as I explained, letting x equal secant theta. The issue with that, as I stated though, was you could get a messy integral. It's going to take much longer to compute compared to this, where it's taking the derivative of essentially cosine and sine. Just think about cosine, hyperbolic sine, which are pretty easy. They're straight back and forth. There's no like complicated memorization here. So with that, I leave you your answer. I bid you a good day, and good luck to anyone else that's trying to participate in this competition. And thank you to blackpenredpen for letting me participate in this. Thank you, and have a good day.